All right, welcome to today's Explainer. We are diving into a massive technological leap today, one that's honestly about to completely disrupt the global energy and electric vehicle landscape. For a long time, the EV revolution has been powered by basically one thing, lithium. But, there's a new challenger stepping into the ring, and it's bringing some serious firepower. Or, well, actually, a distinct lack of firepower, as we'll see in a minute. Today, we are exploring CATL's Naxtra sodium-ion battery. This is a breakthrough that is hitting mass deployment in 2026, and it's fundamentally changing all the rules of energy storage.
But before we get into the nitty-gritty chemistry and all those market projections, I want to start by asking you a rather dramatic question. What happens when you take a high-powered EV battery and literally saw it completely in half? If you know anything about traditional battery chemistries, your mind probably goes straight to catastrophic thermal runaway, massive fires, maybe even explosions. Keep that image in your head, because the answer to that question is at the very core of why this new technology is so incredibly revolutionary.
So, Section 1. Is lithium's throne shaking?
Okay, so lithium-ion batteries have been the undisputed king of portable energy for decades. They power our phones, our laptops, and the vast majority of EVs on the road right now. But that dominance? It comes with a pretty growing list of headaches. Lithium faces real challenges, things like material scarcity, super high extraction costs, severe degradation when the weather gets cold, and of course, a distinct flammability risk. Sodium, on the other hand, offers a really compelling alternative. It's literally one of the most abundant elements on Earth, so it's significantly cheaper. It's incredibly resilient in freezing temperatures, and it boasts a much higher safety profile. Now, for years, the catch was always that sodium just couldn't match lithium's energy density. But actually, scratch that. That narrative has completely shifted.
Moving to Section 2, Naxtra, the sodium-ion revolution.
To really understand this shift, we have to look at CATL, which is the world's largest lithium-ion battery manufacturer. They realized a while ago they needed to diversify. And guys, this isn't just an overnight hype cycle. Look at the sheer scale of investment here. CATL began their sodium-ion R&D way back in 2016. They've poured nearly 10 billion RMB into this project, dedicating over 300 R&D personnel, including more than 20 PhDs, just to develop and test nearly 300,000 individual cells. They essentially engineered their way out of the density and degradation issues that plagued early sodium prototypes. 175 watt-hours per kilogram. This right here is the magic number. This is the energy density milestone that proves sodium can finally sit at the big kids' table. It represents the absolute highest energy density among sodium-ion batteries worldwide, making it directly comparable to and highly competitive with the standard LFP, or lithium iron phosphate batteries that are currently used in millions of EVs. So, in the real world, what does 175 watt-hours per kilogram actually translate to? Some fantastic performance benchmarks. Right now, today, this battery delivers over 400 kilometers of pure electric range. And as the tech matures, they're projecting 500 to 600 kilometers for the next generation. It also boasts ultra-fast charging. We're talking hitting 80% capacity in just 15 minutes at room temp. And perhaps most impressively, especially for total cost of ownership, it's rated for over 10,000 charge cycles. Theoretically, that translates to a lifespan of 3.6 million miles. It's literally built to outlast the car itself.
All right, Section 3, the SAW test, flawless security. Whenever we talk about consumer reluctance to adopt EVs, safety, and specifically battery fires, is always a top concern. To prove unequivocally that Naxtra was fundamentally safer, CATL and their automotive partner Chang'an put this battery through some absolutely extreme abuse tests. We aren't just talking about standard bump and vibration tests here. They subjected fully charged battery packs to massive multi-directional crushing forces. They took heavy-duty drill bits and performed deep drilling directly into the cells. And yes, they literally took a saw and cut the battery completely in half. And the result? Zero. Exactly 0 fires, 0 explosions, and 0 smoke. Even after being physically sawn right down the middle, the battery didn't experience any thermal runaway. In fact, remarkably, it just continued to discharge power normally. By eliminating the combustion-supporting factors right at the material level, CATL has moved battery safety from what they call passive defense to intrinsic safety. Because of this just unmatched stability, Naxtra achieved a massive certification milestone. It became the very first EV traction battery to pass China's newly updated, highly rigorous national safety standard, GB 38031-2025.
This proves beyond a shadow of a doubt that the tech isn't just some cool lab experiment. It is fully validated and totally ready for the mass market.
Which brings us to Section 4, challenging extreme cold.
If you've ever tried using a lithium battery in the freezing cold, you know the capacity absolutely plummets, and charging it gets incredibly slow. Sometimes it's even dangerous because of a phenomenon called lithium plating. So why does sodium perform so much better? Well, it all comes down to electrolyte bonds. In cold weather, the liquid electrolyte inside a battery thickens up. Lithium ions are small, and they form very strong bonds with this thickened liquid, effectively getting trapped and slowing down the power transfer. Sodium ions, paradoxically, are larger, but they form much weaker bonds with the electrolyte. This allows them to just detach easily and slip right through, maintaining high ionic conductivity even when the temperature takes a total nosedive.
Let's put some numbers to that. When you drop the temperature to -20 degrees Celsius, standard lithium LFP batteries retain only about 70% of their capacity. NMC lithium batteries, they drop to about 65%, but the sodium-ion battery, it retains over 90% of its capacity. For consumers and fleet operators up in cold climates, this means reliable range and performance without needing those expensive, energy-draining battery heating systems.
And they pushed the extremes even further. At -30 degrees Celsius, this sodium battery delivers nearly 3 times the discharge power of an equivalent LFP model. And get this, while most battery management systems will completely block a lithium battery from charging below freezing just to prevent permanent damage, CATL's Naxtra can actually safely charge all the way up to 90% capacity at a staggering -40 degrees Celsius. And just when you think they've hit the limit, testing data shows the battery can maintain stable power delivery all the way down to -50 degrees Celsius. I mean, no way. This effectively eliminates the cold weather penalty that has historically held back EV adoption in colder regions.
Okay, Section 5, 2026, a new era in energy. So we've got a battery that thrives in the extreme cold and doesn't catch fire when it gets crushed. Following CATL's roadmap here, we can see the aggressive scaling underway to bring this out into the real world. Following the launch of the Naxtra brand in 2025, 2026 is designated as the big year, large-scale global deployment. CATL is targeting a massive 60 gigawatt-hour supply and expects these sodium-ion cells to reach price parity with LFP batteries by the end of 2026. Looking slightly ahead to 2028, they're already targeting their next generation of cells, pushing that energy density over 200 watt-hours per kilogram with a 600-kilometer range.
Now, interestingly, sodium isn't going to make lithium completely obsolete overnight. Instead, CATL is employing what they call a dual-star strategy, utilizing their free void dual power architecture. They're actually integrating both sodium and lithium cells into the exact same battery pack. This hybrid approach uses software to perfectly balance the two chemistries, utilizing the sodium cells for cold weather starting and safety, and the lithium cells for extended range. It's basically a customized, best-of-both-worlds solution. Looking at the broader market projections, the financial implications of this shift are just immense. The global sodium-ion battery market is expected to grow from $1.39 billion in 2025 to nearly $6.83 billion by 2034. As this technology reaches cost parity with lithium, we are going to see rapid adoption. And not just in passenger vehicles. We're talking commercial fleets, stationary grid storage, and global battery swapping networks. Which leaves us with this final thought for today's explainer. We have seen exactly how CATL has engineered their way past the limitations of lithium, using superabundant sodium to create a power source that totally redefines safety and cold weather resilience. Think about it. If a battery can survive a literal saw blade and -50-degree temperatures while also driving down costs, how long until sodium becomes the undisputed new standard, sitting right there in your driveway? The lithium monopoly is officially over, folks. The multi-power era has begun. Thanks so much for joining me on this deep dive, and definitely keep your eyes on 2026.